So good morning. Today, so we shall see the next topic of the first unit, that is introduction to the damping. So use of damping and its applications. Okay. So first of all, whatever we have seen in before this lecture, so about damping and its uses, about before this, that is vibration. So what are its advantages, what are its disadvantages, so how to what is the effect of that particular vibrations on the systems, and how it leads to the failure of the components. So वाइब्रेशन से क्या होता है कि मोस्ट ऑफ द टाइम इट इज अनडिजायरेबल, मतलब वाइब्रेशन मोस्ट ऑफ द टाइम पे जरूरत नहीं होता है. So only in few applications so it is required. So if it is not required, then how to eliminate or how to reduce that particular vibrations. अगर किसी चीज को जरूरत नहीं तो उसको हमको क्या करना पड़ता है, उसको एलिमिनेट करना पड़ता है, नहीं तो उसको रिड्यूस करना पड़ता है. तो देन how vibration is generally not required in many applications, like in machines, in automobiles. So अगर मशीन में वाइब्रेशन होने से क्या होता है, so especially in manufacturing machines like CNC machines, VMC machines. So in that case, so it leads to the failure of the components, error in productions, like we will not get proper accuracy. So failure of the tools, failure of the different parts of the machines. So this vibrations leads to the undesirable effects, so which is harmful and not required, you can say. So this vibrations is reduced by the using damping. So by using the concept of the damping. So what is meaning of damping? So damping means it is a process where energy is taken from the vibrating system and is being absorbed by the surroundings. तो वाइब्रेशन का मतलब क्या होता है, व्हाट इज मीनिंग ऑफ वाइब्रेशन? सो वाइब्रेशन में क्या होता है, सो इट इज ए टू एंड फ्रो मोशन, दैट इज कन्वर्शन ऑफ काइनेटिक एनर्जी इनटू पोटेंशियल एनर्जी एंड पोटेंशियल एनर्जी इनटू काइनेटिक एनर्जी. वो जो एनर्जी रहता है, तो अगर वाइब्रेशन को उसको रिड्यूस करने के तो उस एनर्जी को एब्जॉर्ब करना पड़ता है, उस एनर्जी को रिड्यूस करना पड़ता है, देन ओनली so we can stop the vibrations. So that absorbing mechanism, whatever the mechanisms we are going to use to absorb that energy of vibration, so that is called the damping. So the whatever the system we are going to use, so that is called the damper. ओके सो रोहित मेरा आवाज आ रहा है?
हाँ सर।
ओके ठीक है ओके
हाँ सर।
ओके ओके ठीक so so this is where we are using the dampers to absorb the vibrations. So types of damping means how we are going to classify the dampings. So dampings are classified into different types. So based on the technique we are going to use to absorb the energy of the vibration. वाइब्रेशन का एनर्जी को अब्जॉर्व करने के लिए, उसको रिड्यूस करने के लिए जो टेक्निक यूज करते हैं, तो डिपेंडिंग ऑन दैट पर्टिकुलर टेक्निक, सो वी आर गोइंग टू क्लासिफाई द डैम्पिंग. तो फर्स्ट वन इज विस्कस डैम्पिंग. So and next one is, second one is column or dry friction damping, and third one is the material or structural or stress damping. So viscous damping. Viscous damping means here we are going to use the oil dash part. Suppose if you take the example of the piston and cylinder. अभी देखो एक इसमें अगर ऑयल है उसके अंदर अगर हमने आपको पुश करने के लिए कोशिश किया तो क्या होता है? सो ऑयल जो है उसको मोशन के लिए रजिस्टर करता है, रेजिस्टेंस देता है. लाइक सपोज अभी हम इन व्हीकल्स, so what we do is, so we do the oiling of the different parts where there is some relative motion between the parts like gears, clutches, brakes. So why? So because of that oiling, so there is a less amount of vibrations. It leads to the less amount of vibrations. Means it acts as a damping. It absorbs the energy of vibrations. So that type of damping is called the viscous damping. Means where we are going to use viscosity property of the liquids or gases. So next is column or dry friction damping. So here we are going to use the friction as the damping. And third one is the material or structural or hysteresis damping. So in this case, so we are going to use some particular materials like if you see in the vehicles, so there are some especially that wheels are mounted on the, so wheels are mounted by the special some thin seats, so which acts as a damping. Means like suppose if you see in the two-wheeler also in the back side, so there are some particular type of springs, so which will give the suspension to the vehicles. Like means in this case, so we are going to use the some material, some structures, some hysteresis. तो hysteresis मतलब क्या होता है? So पहले से एनर्जी स्टोर किया रहता है, तो जो वाइब्रेशन का एनर्जी को उसको एब्जॉर्ब करने के लिए. तो दिस इज third type of damping. There are many other types also, but these are the main three types of damping. Okay. Okay, so this is the best example so of damping. अभी देखो, when the small child is playing this, so initially हम क्या करते हैं, उसको पुश करके छोड़ देते हैं. तो उसके बाद क्या रहता है, उसका जो डिस्टेंस ऑफ दिस प्लेइंग, तो इट गो ऑन reduces. मतलब उसका जो एम्पलीट्यूड है, so that is go on reduces. So why it happens is, so it happens because of the damping effect. It happens because of the damping effect. Okay, so this is one type of damping. So means a play करने के टाइम पे damping किधर होता है? So damping is the air. So whatever the air surrounding us, so it also acts as a damping. So and also, so whatever the gravitational force, so that also acts as some damping. Next you can see here, so this is viscous, which I explained earlier. So whenever you move this material inside this koi bhi material, so this is a liquid like oil, some other liquids, etc. So here what happens is, so when you want to move this body under this liquid, तो उस टाइम पे क्या होता है, it gives the smooth motions without any much vibrations. So that liquid also act as a damping to this particular system. So in many cases we are also going to use the springs to absorb sudden shocks and vibrations. So it also acts as some damping. So देखो, so अभी मैंने I have explained you about the equation of motion for undamped vibrations, undamped free vibrations. मतलब undamped means जिसमें वो damping नहीं होता है. So here is the equation of motion for the damped vibration. Free, damped. Free मतलब no external force. Undamped means no damping. Damped means with the help of damping. So it is a equation of motion for the free damped vibrations. So this is the system. So this is a spring, this is a mass, and this is a dashpot. This is a damper. So damping ka, this is a symbol for used for the damping purposes. So again, this is if you अभी जैसा हमने किया था इक्वेशन ऑफ मोशन में डेरिवेशन किया था. So if you apply same equilibrium diagram, so we will get the equation of motion as, so mx double dot plus cx dot. देखो पहले जिसमें डैम्पिंग नहीं था तो ये टर्म नहीं था, देयर वाज नो term of damping. So in this case only addition of the damping component, that is mx double dot plus cx dot plus kx is equal to 0. So this is the equation of motion for free and vibrations. Okay, so okay, okay, so this is the damping ratio, so which is used to find the effectiveness of damping. Means if critical damping, this cc indicates it is a critical damping, means vibration को just reduce करने के लिए कितना damping चाहिए, minimum damping. So that is called critical damping. So c indicates it is actual damping. अगर c is equal to cc मतलब दोनों का वैल्यू इक्वल है तो क्या होता है, जीटा इज 1, मतलब damping ratio is equal to 1. So उसको क्या बोलते हैं हम, it is critical damping. So देखो इसमें I am going to just explain different underdamped vibration. Undamped अलग होता है, underdamped मतलब damping value is, damping ratio is less than 1. तो इस टाइम पे क्या होता है, C is less than CC. इस टाइम पे क्या होता है, तो there will be some vibrations. So natural frequency is given by omega n is equal to square root of k by m. So you just remember these equations, relation between damping, damping ratio, mass and natural frequency. So this indicates how this critical damping constant C can be calculated. So critical damping Cc is given by It is 2m omega n. So if there is any body, so its natural critical damping is given by 2m into omega n. M means it is mass, omega n means it is natural frequency. Omega n means instead of omega n, so we can also use the square root of k by m. So overdamped system, overdamped vibrations. Overdamped vibration means when zeta is greater than 1. When zeta is greater than 1, so we say it as a overdamped. मतलब C is greater than CC. So इसको हम क्या बोलते हैं? Overdamped system. मतलब damping ज्यादा है, जितना जरूरत है उससे भी ज्यादा है. So this is about different amplitude of vibration for different damping. देखो heavy damping है तो amplitude कम होते जाता है. No damping है तो amplitude देखो, amplitude is increasing, amplitude is more, मतलब vibration is more when no damping. जैसे जैसे damping बढ़ते जाता है तो वैसा वैसा vibration का जो amplitude है वो कम होते जाता है. मीन्स तो vibration कम होता है अगर आप damping को बढ़ाए तो उससे क्या होता है? Failure of component is going to reduces. Damping is useful in reducing the vibrations. So next is logarithmic decrement. So logarithmic decrement means it is okay. Okay. So logarithmic decrement means it's very important term. So logarithmic decrement means it is defined as the natural logarithm of the ratio of any two consecutive amplitudes on the same side of the mean position. So I will explain you with some concepts. Because this is the indicates amplitude of vibrations. Okay, so x-axis indicates amplitude and y-axis indicates it is omega d into t. मतलब damped vibration with time, that is time period. देखो amplitude means amplitude is measured from mean position to the peak values, peak position. So amplitude क्या होता है? Go on reduce होता है अगर if there is a damping. So let us say here it is amplitude is x2 and it is x3. So logarithmic decrement is given by natural log of x1 by x2. तो x1 by x2 मतलब क्या होता है? देखो x1 किधर है? It is the x1. Here amplitude of vibration is x1 and here it is x2. मतलब logarithmic decrement means it is natural log of ratio of the any two successive amplitude of the vibration on the same side of the mean position. नहीं तो इसमें क्या ले सकते हैं आप? डेल्टा इज इक्वल टू लॉग ऑफ x2 by x3 भी ले सकते हैं. मतलब ये सक्सेसिव होना चाहिए, कंसेक्यूटिव होना चाहिए एम्पलीट्यूड्स. Okay, so this is about the logarithmic decrement. Okay, so I'm going to stop here. So in the next lecture, so we shall see the problems on this free vibration and damping. Okay, so thank you. See you, guys. See you in the next lecture.